All right, today we start chapter 2. Our objective today is going to be to graph relations and identify functions. Graphing relations. A relation is a set of pairs of input and output values, written as ordered pairs. You can graph a relation on a coordinate plane. All right, we are asked to graph the relation. We are given these curly brackets that denotes a set. So we are given a set of ordered pairs to graph. You have a nice coordinate plane there on your notes. I don't have one of those, so my graph is going to look a little messy. Remember, when we graph in a coordinate plane, our ordered pairs are x, comma, y. We start at the origin, we move along the x-axis first for the first number, and then we move along the y-axis for the second number. For example, for -2, 4, we start at the origin, we go -2 on the x-axis, and then +4 up along the y-axis. So that is where our first point should be. Again, you have the coordinate plane on your notes, so yours should look much neater than my hand-drawn one. Who can tell me where to go to get to 3, -2? Sadia.
To the right 3 and down -2.
To the right 3 on the x-axis and then down 2 on the y-axis. Very good. All right, somebody else. -1, comma 0. Charles?
Left 1 and then just leave it there.
Left 1 and leave it there. Very good. Trying to make my points a little bigger. All right, what about 1, 5? Izzy?
Go over to right 1, go up 5.
Good, right 1 and then up 5. When we graph relations and we're given a set of ordered pairs, all we do is graph those points. We are not playing connect the dots. We are not drawing lines. We were only asked to graph those specific points, so we leave it at that. For domain and range, the domain is the set of all input values. We also refer to them as the x-coordinates of the ordered pairs. The range is the set of all output values. Those are the y-coordinates of the ordered pairs. All right, we are asked to give the domain and the range of the following relation. When we give a domain and a range, we are going to list them as sets, meaning they're going to be in the curly brackets. So let's start with domain. So I open my curly brackets up. I'm not doing ordered pairs, so I'm not using any parentheses. We go in order from least to greatest. So for domain, we're only looking at our x values. And we want to start with the lowest one. So out of all the x values we see here, which one's the smallest? -3, comma, the next smallest. -2, comma, the next smallest. 0, comma, the next smallest. 1, comma, 2. Okay, so we listed all the x values. We did not necessarily go in order through these ordered pairs, right? We pick out the smallest first, and then we keep going until we get to the biggest one and we stop. We're going to do the same thing for the range. We're going to list it out in curly brackets starting with the smallest. So for range, we are looking at the y values of all these ordered pairs. What's the smallest? -2, comma. We see a -2 again. We are not going to list it twice. Only list each one once. Okay, so we can cross off both of those -2's. What's the next smallest y? 2, and then, and then. Is that all of them? Okay. So important things to note. We did not necessarily go in the same order that we did with the domain. So these don't match up with each other. We went from least to greatest. We only write each number one time on each list. All right, on number 3, we're doing the same thing. Domain is the x values. Who can tell me what should go first for my domain on number 3? Do we have -4 as an x? No, -3 is the smallest x. Then what? -1, then 1. Are there any others? Nope, that's it. All the other ones are just repeats. For our range, we are looking at the y values. Smallest one is -4, then -2. What comes next? 1, and then 3. I think that's all of them. A mapping diagram is another way to show a relation, is to make a mapping diagram, which links elements of the domain with the corresponding elements of the range. We need to make a mapping diagram for the relation. So this time, because I've got a little more space, I'm going to list my domain and range vertically instead of horizontally. So I'll start with my domain. So I'm just going to list them down. I still want to start with my smallest. Domain is x values. What's my smallest x value? And then?
-1.
And then?
3.
Any others?
No.
Okay. Then I'm going to do my range. Smallest y value.
-10.
And then?
-2.
Then?
2. 2.
2.
And 6.
And 6. Okay, so now we're going to draw a map from the domain to the range. So I'm going to draw an arrow from -5 to its output in the range. Where is its output?
-10.
-10. So this one happens to just go straight across. What about -1?
-2.
Again, it's more or less straight across. What about 3?
2.
2 and 6. Okay, so from 3, we've got 2 different arrows. One going to 2, one going to 6. A function is a relation in which each element of the domain is paired with exactly one element in the range. So it's a specific type of relation. In other words, the domain numbers cannot repeat. The range numbers can repeat, but the domain numbers cannot. All right, for examples on number 5, we are determining if the relations are functions. So we will either say function or not a function. Remember, the very last line that we filled in said that domain numbers cannot repeat in a function. Domain being the x values. So if we were to be looking at the x values for 5a, do we have any domain numbers that repeat?
Yes.
Yes, the -2. We see that twice. As soon as we see that, we know that this is not a function. If domain numbers repeat, it is not a function. What about on part B? That is a function. We do not care that range values repeat, so that's fine, as long as the domain values do not repeat. So this is a function. Nice and slow. The vertical line test. By graphing a relation on a coordinate plane, sorry, trying to get my pen on. By graphing a relation on a coordinate plane, you can tell whether a relation is a function. The vertical line test can be used to determine whether the relation has at least one element of the domain paired with more than one element in the range. If a vertical line passes through 2 or more points on the graph, then the relation is not a function. Okay, so here we've got 3 different graphs. We are going to determine if they represent functions using the vertical line test. So we discussed vertical lines go straight up and down. So I'm going to draw vertical lines on the graphs. If a vertical line touches more than 2 points on a graph as it goes through, then it is not a function. It fails the vertical line test. If I can draw vertical lines wherever I want and it only ever crosses the graph one time, then it is a function. It passes the vertical line test. So for A, if I start over here on the left and I make a vertical line, that vertical line only touches my graph at 1 point there. So far it's passing. But if I jump into the middle here and draw a vertical line, then how many times is that vertical line touching the graph? 3 times. Because it touches it 3 times on this vertical line, it fails the vertical line test. A is not a function. So just because it passes it sometimes doesn't mean it's going to pass it everywhere. All right, we move on to B. So if I start drawing vertical lines through this graph, see it touches once there, so I move over and try another one. It's touching once there, I move over, try another one. Do you see anywhere on this graph where I could draw a vertical line where it would touch more than 1 point on my graph? No, there isn't. I could draw all the vertical lines I want, and I'm only ever going to touch the graph 1 time, which means that this is a function. What do we think about C?
That's a function.
C is also a function. It's squiggly just like A, but we again can draw vertical lines through it, and even though it gets pretty steep at some points, we're only ever crossing it one time for each vertical line. Okay, so draw all the vertical lines you want. You're only ever crossing it one time. Here. Okay, so we would say that this one is also a function. For function notation, one type of function notation is called f of x. It is written with an f and then an x in parentheses. We would read it out loud as f of x, a function of x. Okay, so we were just pointing out that our variable inside our notation should match the variable being used, so I changed that a to an x, f of x, not f of a. It's possible to have a function in terms of a, it's just not what we're doing right now. All right, back up to 7. So we have the function of x is equal to 3x minus 5. Find f of negative 3. What do you think we're going to do with this negative 3? Plug it into the x. Okay, so instead of a function in terms of x, we want the function evaluated at negative 3. So f of negative 3 is equal to 3 times negative 3 minus 5. And then we just have to evaluate it. What is 3 times negative 3? Negative 9 minus 5. 14. Good. So the function evaluated at negative 3 is equal to negative 14. That is our answer. For part B, we are evaluating the function when x equals 0. Not necessarily. We're still going to plug that in and then evaluate it. Okay, so we plug 0 in for x and then evaluate it. 3 times 0? 0 minus 5 is negative 5. So the function evaluated at 0 is equal to negative 5. Okay, in order to have enough room to show some work on number 8, I'm going to erase the top here. So are we all okay if I erase the top right now? No one's going to yell at me? Okay. All right. 8a is asking me to evaluate this new function at negative 16. So our function evaluated at negative 16. I have 3/4 times negative 16 minus 1. You can type this into the calculator to do it for you, or you can know that you're going to divide by 4 and multiply by 3 to that negative 16. Either way, 3/4 times negative 16, what did we get? Negative 12. Still subtracting 1 from that, so we get negative 13. So the function evaluated at negative 16 is equal to negative 13. Next, we're going to evaluate the function at 1/2. So the function evaluated at 1/2, I take 3/4 times 1/2 and then subtract 1. What is 3/4 times 1/2? Remember, we multiply straight across? 3/8. And then we're still subtracting 1 from that, so you either need to get a common denominator or use a calculator. We get -5/8. And that is our answer.